Hello, you all probably know how banks and ATMs work. Today, we are going to tell you how we can ensure safe behaviors of an ATM. Let's assume that there is a bank and one day they decide to build some ATMs. So they ask an engineer to help them out.
Hey, can you help me build an ATM?
Sure, I'll try to come up with an idea. Hmm, to build an ATM, we have to describe its behavior first. How does an ATM work? If no one is using the machine, it is in an idle state. Now let's think about what happens when someone starts using it. First, the person has to insert the card. The machine reads the card and asks for the PIN. If the person provides a wrong PIN, it goes back to being in the idle state. And if the person enters the correct PIN, it should give two options: check balance or withdrawal. Assume that the person selects the balance option, then it should print the receipt showing the balance. And upon selecting the withdrawal option, it should ask for the amount. Now the person can enter the amount and get the money. After printing the balance or giving the amount, it should ask if you want to do more transactions or not. Selecting more transactions should give the two options again, and in the other case, it should go back to the idle state. What we built here explains how an ATM works, and it helps to study the effects of different components and to make predictions about its behavior. We call this a model. These are called states, and these actions are called transitions. Now let's take this model to the bank. Hey, I have a model for the ATM.
Great! Let's ask our experts if it satisfies all the necessary properties.
Hello, I heard that you have a model of an ATM.
Yes, here it is.
Does it satisfy the property that if a person provides the wrong PIN, he cannot access the account?
Yes, after inserting the card, we are in the PIN state, and if you provide a wrong PIN, it will always go back to the idle state.
Great, that's perfect. Now, suppose I want to withdraw 500 rupees from my account. Does your model do it correctly?
Yes, from idle state, you insert the card and give the correct PIN. It will take you to the opt state, and there if you select the withdrawal option, it goes to the amount state and asks for the amount. You can enter 500, it will give you the cash and take you to the more state. Then you can end the transaction.
Great. But I see a problem. Suppose I have only 100 rupees in my account and I try to withdraw 500 rupees. Your model will give me back the amount following the same path you explained, which should not happen, right?
You are right. There is a mistake. Let me think. Oh, I have an idea. Why don't we add another state that checks if you have sufficient balance to withdraw the amount you entered?
Yes, that's a very nice solution. Now, if I want to withdraw 500 rupees, it will first go to the check state and will tell me, no, you do not have sufficient balance. If I give rupees 100 or anything less as the amount, then only it will give me the cash. Great. Thank you very much for your model. The process just happened right now is called model checking. The engineer had a model of an ATM and the expert had some properties in his mind. For every property, the engineer showed that it is satisfied. Let's see the model checking process in a flowchart. First, we have a system and we can come up with a model describing its behavior. Then, we have some required properties that we need the model to satisfy. These are usually encoded as specifications in different types of logical formulas, typically in temporal logics like LTL, CTL, etc. Once we have the model and the property, we check if all runs of the model satisfy the property or not. Well, if it does, we are very happy. If not, we get a violation or a counterexample and we try to fix the model as it was shown for the ATM. Three famous scientists, Edmund Clerk, Alan Emerson and Joseph Sifakis, introduced this model checking technique in 1981. They received the very prestigious Turing Award in 2007 for their pioneer work in this field. Now, the next natural question should be, why model checking? Well, a lot of safety critical systems require model checking to ensure that they behave properly. This procedure essentially helps to find bugs in their software. A very teeny tiny software bug can produce deadly problems. Let me give you a few examples from history. Therac 25 was a computer-controlled radiation therapy machine for curing cancer patients. Unfortunately though, it was involved in at least 5 patient deaths between 1985 and 1987. It gave massive overdoses of radiation due to a software bug in the program. The next example is about the MIM-104 Patriot. It is a surface-to-air missile system which was used by the army to intercept any incoming missile attack. On February 25, 1991, an Iraqi Al-Hussein missile hit the barracks in Saudi Arabia, killing 28 soldiers from the US Army. Investigation revealed this happened due to a software bug in the system's handling of timestamps. Deadly, isn't it? Let's see our last example for today, and this time it's about space. On June 4, 1996, Ariane 5 rocket launched by the European Space Agency exploded just 40 seconds after its liftoff from the ground. It was due to a bug in the onboard guidance software. There have been a lot of such instances where a bug in the software has caused devastating results. Traditional testing methods also are not sufficient for these safety critical systems. But then, model checking in these cases has been very successful in recent years. It is also a growing research area. Well, are you not convinced yet that this is the hero the modern world needs right now? Similar to these systems, you can model a lot of other things as well and check if they satisfy some property. Can you try to come up with a model from your surroundings or daily life? It will be great fun, I promise. Let us show you an example. We made a model of you watching this video. You can pause the video here and try to understand the model. Well, are you in this state yet where you want to know more? If yes, you can search model checking on the internet and start reading the books and articles. Let us help you with this beautiful book named Principles of Model Checking by Baer and Cutwin. Well, that's it for this video. Thank you for your attention and happy modeling.